Hi all, in this video we'll be seeing about a query with respect to CDC. Right. So here we'll have the asynchronous FIFO, whether the depth of the asynchronous FIFO, can it be a non-power of 2 is the query that we'll be answering in this video. So in case of an asynchronous FIFO, like we will usually see that, right, we have the memory here, and we will have the write pointer generation and the read pointer generation, write pointer and full generation here, and the read pointer and empty generation coming from this block. So we'll basically the depth of the FIFO, right? Usually it is a power of 2. So how do we maintain that? We kind of uh, have these pointers. Actually we have these conversions, right, where we convert the whatever write pointers and read pointers coming from this block, write pointer from this block to gray here, and then synchronize it and then check it with whatever read pointers from this block, and then generate the empty here. Same thing from here, we convert the read pointer here to gray here, and then synchronize it and we check it with the right pointer here, and generate the full condition at this side. So this is like the right side and this is the read side. So basically let us take 8 deep FIFO. So in case of 8 deep FIFO, it will go from 000 001 010 5 6 and 7, and the respect to gray code is like so it's basically becomes right. Yeah, it is basically the mirror image of the first two bits. So 1 0 and then 1 1, then next 0 1, and then 0 0. So basically this is the mirror image of the first two bits. So just right, we'll have 1 0 here, and then 1 1 here, and then 0 1, and then 0 0. Then we add the other bit here, 1 0 1, and then this is 1 0 0. So here if you see the distance between any two consecutive the pointers, right, it is one bit actually, since it's a gray, this is the binary. So one bit, one bit, one bit, one bit, one bit, one bit, and one bit here. But yeah, so here we do not have any problem. So since the gap is just one bit here. But let us take in case of a non-power of 2 now. So let us take the depth of the FIFO is let us say 6. So in case of 6, we go from 0 0 0 0 0 1 0 0 1 1 0 1 0 1 1 0. So this is 0 1, this is 1 2 3 Yeah, just make it more clear here. 0 0 0 0 0 1 0 1 1 0 1 0 1 1 0 1 1 1. So this is basically 0 1 2 3 4 5. So this is basically the six deep FIFO. So where it goes from 0 to 5 here. So what you observe it when we go from 0 to 1, its distance is 1. 1 to 2 distance is 1, and here again 1 1 1. But if you see when it rolls over, right, from 1 1 1 to 0, we see that all the 3 bits are changing. So distance basically here is 3. But if we look at in case of the depth of 8, right, that is the power of 2. In that case, we see that the distance is just sorry, there's a binary one. So here we see that the distance is just 1. So this is the major issue with the non-power of 2 case. So how do we resolve this? So the problem here is because it is starting from 0. So we will try to try to shift this 0 to 5 in a such a way that the distance just becomes 1. Right? So we have a formula for the same. The formula is 2 power n by 2 minus FIFO depth by 2. From this will be the starting range, 2 power n by 2 plus FIFO depth. I just make it as FD by 2 minus 1. So this will be the starting and ending of the right and read pointers instead of 0. So let us take for the case of 6 deep FIFO. So in case of 6 deep FIFO, it is 2 power 6. Sorry, n is uh, so this is actually the FIFO depth, and n is actually the closest. So it is the closest power of 2. So here actually the closest power of 2 will be actually 2 power 3, right? So that will be like actually 8 here. So 8 by 2 minus 6 by 2 to 8 by 2 plus 6 by 2 minus 1. So what is it? It is 4 minus 3 to 4 plus 3 minus 1. What is it exactly? It is 1, 2, 7 minus 1, which is 6. So now just let us see. So starting with 1, 0, 0, 1, and then go for 1, 1, and then 0, 1, 0. Go for 1, 0, and then 1, 1, 0, 1. So we are going from 1, 2, 3, 4, 5, 6 here. So here now we see that we just have a distance of 1 compared to the earlier case, right? So we will be starting with 1 instead of 0. So this will resolve the problem that we were facing with earlier. So I guess clearly you would have understood now. Using this formula, you will be able to use a power of 2 depth for the FIFOs, asynchronous FIFOs, right? So now going on to the let us say odd number, right? So in case of odd number, the same thing, right? We can make use of it. Let us say we have a depth of 7, right? So in that case, we can actually make use of the depth of FIFO as 8 actually. So just one extra depth is going to be fine. So we will make use of depth 8 in case the it is a odd number, and then you make use of the same. So here I think whatever we saw earlier, same applies here. And yeah, in case it is 9, we'll go for 10 and then use the formula that you already see. So thank you. Please let us know if you have any queries. Thank you.